Okay, so last time I showed you how to make a circuit using an LED resistor, some junction block and a USB connection. So there's my working circuit. Now here's the circuit diagram like I showed you before. We've got the symbol for the battery or the power supply and the symbol for the resistor, which reduces the current going to the LED. Now we're going to make that circuit a little bit better, right? So I'm going to unplug that from the power a second. And what we're going to do, we're going to add a little bit of a control system. Now it's not too complex, a control system. We're not quite into the programming that we're going to get onto, but what we're going to do is we're going to have a method of turning the LED on and off. So let me just replicate that circuit diagram. Okay, so this time round, look, for my power supply, I'm just going to draw two little circles like that with a plus on one and a minus on that one, and we're going to have our 5-volt power supply, DC, direct current, and we're going to have a negative conductor that's tracking straight over to our minus side of our LED. Those two little lines that say that that's light coming off it, so it's a light emitting diode, not a plain diode. Now this time around, look, I'm just going to put the resistor above it. There's no difference from putting it up here, it's fine, you can draw it by there. It's still a series circuit, everything goes through. That is a 150 ohm resistor, remember. Now there's the other side of my resistor. I've saved the top part of this circuit for something. Now what I've saved it for is a break in the conductor that I'm going to be able to close off using a switch. Okay, so we're going to add a switch to our lighting circuit. Right, now the first part may look a little bit radical, don't be worried. Choose where you're going to have your switch and you're going to cut the cable. Okay, so by doing that, now what you've done is you have broken the power supply, so the power cannot get over that gap, obviously. So what you got now is kind of positive, negative. The positive wire is going to go up to here and it's going to stop, and that's going to be our switch. Now the negative wire, look, needs to go straight to the LED. So what do I need to do? Well, I need to get the negative wires and I need to join them back together. So I'm going to strip these wires now, look, 1, 2, to expose the conductors. They're color coded, remember, so red is plus, black is minus, positive and negative. I need to rejoin together the blacks. Right, so strip the black conductors. Now look, you have to be really careful when you strip these wires. They're very thin and they're multi-stranded wire, multi-core wire. Now what that means is it's more flexible, but also it's a bit more fragile. There's lots of little thin strands of wire inside there. Now what the best thing to do is to twizzle those around, just twist them around, look, and don't forget what we're going to do. We're going to bend that wire back over the plastic, so it's sat over the plastic. That's quite useful. And we're going to get another piece of junction block. I've got 3 blocks there, junction block, and I'm going to loosen off one of the connectors so that I've got a little gap underneath the screw. And I'm going to put my negative wire that I've just stripped there underneath that connector. So it's fitted in place. So there's my negative wire. Now, remember, I want to join the negative to the negative. So I'm going to put that one on that side into the same junction block. Loosen off a bit first. Slide it under. Tighten it up. So my negative now is joined back up. Okay, my positive now, next side to deal with. Right, so my positive one is a little bit different. Now with my positive one, look, I might find that I'm going to run out of space here. I'm going to have to be a little bit careful. Hang on. Probably should have stripped this first, shouldn't I? Pop that in there. Strip that wire. And strip this side as well. Okay, so I've got 2 red wires. Now I do not want to put them in the same row of my junction block, otherwise the light would just be on constantly. I've got to put them in different rows. So the first one I'm going to put in the middle row. And the second one I'm going to put in the end row. Okay, should have made that a bit longer, look. Right, hang on, dashboard measures called for. Going to break that insulation back a little bit further. Give myself a bit more leeway, a bit more stretch. Okay, just going to go under there with a bit of persuasion. Okay, so I don't know if you can see that now, look, but I've got my black wire that goes to the other black wire in the same junction block. I've got my red wire that comes from my power supply that goes into the middle row, and then my red wire that goes up to the LED is in a separate row. So these two are not joined together. The reds are not joined together. Right, next stage then will be to find a way to join those two blocks together, and that's what your switch is all about. So for your switch, what you're going to need, generally speaking, is another piece of red wire. Now the red wire that you've got needs to be in two pieces, and if I bend those back, I'm going to put one of them into each of the spare blocks, and there should be two of them. One in there and one in the other. And there is my switching loop. Right, so does that make sense? Hopefully, if I'm holding it in the right way. Right, question. Why do I always put the switch on the positive side of the circuit? Because that's generally the way we always do it. The positive side of the circuit is the one we break. Why? Well, because when the power is removed, the positive side of the circuit is removed, there ain't no power going to the LED. So it makes the component safer. So that makes sense. So that is dead. There's no live to that once we've disconnected the switch. It's live up to the switch, but past the switch it's all dead. Alright, so there's your switch. Now the idea is, how are you going to join those two wires back together to make the light turn on and off? And that is your question when it comes to designing a switch that you're going to use. Obviously some of you are going to take it a bit further and use microbit, but for making a switch in a circuit, that's a good way to think about doing it without a soldering iron, don't forget.